Okay, not the smoothest fade out ever, but we'll deal with it. Oh, I just realized I forgot to turn on one of my lights. Whatever, it's fine. Welcome, hackers, to Saturday Hacker Day. Thank you for choosing to spend your time here instead of at a DEF CON stream or actually in Vegas. Not quite sure what you were thinking, but I'm glad that you're here. My name is Taggart, and as always on Saturdays, we're going to start with a little bit of review of the week's cyber news. Not that much to talk about today that hasn't already been talked to death with regard to Windows vulnerabilities, right? Petit potin, things like that. But we did have something really, really interesting happen today, and that was a dump of manuals and resources from the Conti ransomware group. This was really, really cool. About 80 megabytes worth of information was dumped by, as near as we can tell, a disgruntled associate that worked with the Conti ransomware gang. Now, if you're not familiar with Conti, just a quick review, this is the group that has been specifically targeting hospitals. So really upstanding folks that we're talking about here. Conti has gone after and successfully ransomed over 400 healthcare organizations, and most of them have been in the United States, but they've also targeted some in Europe. Most recently, I think their highest profile is likely Scripps, down near San Diego. And what we've learned from this dump was I spent all yesterday translating every single text file in this thing from Russian into English in Google Translate, which is pretty interesting to do. I do not speak Russian, and so that was a bit of a task. What I've learned from this and what others have reported on is, you know, Conti is a business, ransomware is a business. Crime bosses are still bosses, basically. And so to find talent and to hire people, they basically try to streamline the process so that onboarding is easy. And so what you see in these documents are all these step-by-steps how to execute malicious activities on networks in a controlled fashion so that they can reproduce results no matter who's running the operation. And the other thing that was really interesting to me about their documentation was that, of course, it was a very step-by-step. They even alias things, they shortcut things so that it's easier, faster for people to learn how to do things like Metasploit or Cobalt Strike modules. But the other part that was really interesting to me is that there's not a lot of technical sophistication with this particular set of materials. Now, this probably isn't everything that Conti is doing, and we know that from other malware samples that Conti does build, custom payloads for their targets to try to avoid antivirus and EDR, things like that. But it was really interesting to see that kind of their baseline is really not that technically sophisticated. They're doing attacks that you would learn how to do as a pen tester training for the OSCP or for other kind of entry-level pen testing certifications. They're doing Kerberoasting, right? They're doing golden tickets. They're looking for well-known 0 days. One of their first attacks is using Eternal Blue, right? MS 17010. They're looking for zero logon. These weren't really especially tricky things to defend against. And as a matter of fact, in a mature, vulnerability managed environment, a lot of these should be stopped and certainly should be detected. But the truth is that many organizations don't look like that. And so these attacks are going to pass without notice. There's another really big part of their process that is kind of the elephant in the room for me, and I've been really struggling with this for a while, which is that every single one of these actors is using Cobalt Strike. And I think we need to have a conversation at some point about Cobalt Strike. Look, I think it's important that we have offensive tools that are open source and even commercial tools so that red teams and pen testers can do their jobs. But I also think we need to have a bit of a reckoning here about the fact that all of these ransomware gangs are using Cobalt Strike to do what they do. And the reason that they're using it, right, not only because the source code was leaked so they don't have to pay for a license, and so they can bypass help systems sort of vetting process that they use for whom they sell Cobalt Strike to. But the nature of Cobalt Strike is such that it's very easy to create difficult to detect beacons on endpoints. And so once you establish that foothold with Cobalt Strike, unless you have a really, really solid detection architecture in your environment, you're not going to get caught. And it keeps working for a reason. Now, we also had a report this week, excuse me, about a vulnerability in Cobalt Strike where you could essentially, if you detect what server, what C2 server is hosting the command and control framework, you can actually send a request to that and create a denial of service situation for the attacker. But it raised a question of, shouldn't there be a kill switch? Shouldn't there be a kill switch? So if you're using Cobalt Strike legitimately, right, during a pen test or during a red team, and the blue team detects you and you're supposed to shut it down, great, knock it off, right? If you detect and identify that it is Cobalt Strike, attempt to fire off that kill switch, shut it down. The red team can report, hey, you found us, good job, here are the rest of our findings. Manolia Lunar, thank you so much for the follow, you're very welcome. But if it's being used maliciously, why wouldn't you want to have a kill switch, right? To be able to say, hey, somebody's trying to use Cobalt Strike in our environment. Okay, well, this is how we shut it down. Obviously, that would be patched. That would be, undone in some other way. And attackers would move on from this particular... It's always cat and mouse. They would move on from that particular technique. But as commercial software, I do think we have to have a reckoning about how this offensive tool has become so universal in the criminal world of ransomware in particular. So some food for thought on that. So today we are doing malware analysis with the REMnux Linux distribution. Now, if you're not familiar with REMnux, think of it as Kali, but for the blue team. It is a custom-built Linux distribution that focuses on malware analysis. It has forensics tools and incident response tools on it as well, but specifically it's there for investigation of malware. And so that's what we're going to be doing today. We're going to start on TryHackMe, because TryHackMe has a room that walks us through REMnux and gets us familiar with the tools that are inside of it. But then we're going to use our own REMnux VM and analyze some real malware and see how that goes. And let me just cut over to our live scene here. Now, the first thing that I've done, and I'm actually still getting this started because it takes some time, is I'm setting up our VM first. And let me also just show you the REMnux documentation is fantastic. It's one of my favorite parts about the project, actually, is how good the documentation is, including step-by-steps for different investigative procedures that you might have to follow. Really, really cool stuff in here. But there are two options to set up REMnux. One of them is to use the OVA, which I tried and it failed miserably. So I'm not sure what's up with that. So that was one thing. So I tried using the OVA. The other is to install it on top of a previously existing instance of Ubuntu 20.04. So that's what I'm doing. I've got 20.04 installing in Hyper-V, and then once that's done, I will install the REMnux tools using their CLI. So it could take some time, which is why I'm getting that going right now. But yeah, I recommend doing it this way because, I've run into this a couple of times with kind of pre-packaged tools like Security Onion, for example, where if they provide an OVA or they provide kind of an installer, it doesn't work as well as just putting it on top of a vanilla Ubuntu image, just because it's kind of a known quantity. So I prefer doing that whenever possible. And then the other reason I like that is that if I have to configure it in some other way or add some of my own tools, I know my way around the operating system well enough that I can do that without worrying about it breaking something that the pre-built system is going to be relying on. So we're going to let that kind of cook in the background for a minute. And let's go check out the TryHackMe room for REMnux. So we're right in here. I've got the machine started. We've got our IP. Let's get some music going. And we will start reading through. So the first thing that it asks us to do is analyze malicious PDFs. Still around, still relevant, so let's check these out. We're going to look for embedded JavaScript inside of a PDF. And so let's talk for a second about what that would mean. If you have JavaScript inside of a PDF, what can that do? Well, if you have JavaScript in there, it could actually execute, right? Or kick off a browser session, download code, something else. You see here, you can get like a pop-up window as well. So we want to look for malicious JavaScript inside of PDFs. And luckily, it turns out REMnux has a tool really, really handily to extract interesting objects from PDFs called PPDF. That could not be more awkwardly named. And so we're going to see what that tool can tell us about this demo not suspicious.pdf. Also, I don't know if any of you have ever really looked into how PDFs are constructed, what the spec is on them. It's madness. It's an absolute funhouse of stuff. PDFs are not really standardized in any meaningful way. So you can just have all this crap piled in there. And as long as it looks okay and the end result, it'll work fine. But that's why often in PDFs you'll have trouble selecting things, or text boxes are like under other text boxes or whatever. It's crazy. So anyway, we'll use PPDF and see, or PeepDF maybe would be an easier way to say that, and see what it can see. I am SSH'd into the machine here. I'm going to zoom that in just a little bit more so it's readable for everybody. PeepDF, and we're going to do not suspicious.pdf. Okay, so what do we get here? It gives us some basics, the MD5, the SHA. Now, best practice would be we take this hash and immediately go toss it at something like VirusTotal, right? Just to see if it knows about it. And presumably it does. We have one detection, right, from Sentinel-1, so that's interesting. Hey, Ogosoro, good to see you. Thanks for checking in. All right, what else did it tell us? It's unencrypted. It has objects with JS code 6. Okay. Now, I should read through the instructions, but I'm really bad at doing that, so I'm going to just see what else PPDF can tell us. And can it extract? Can it extract the stuff? I don't want to execute any of the commands. Okay, so interesting. To extract this JavaScript, we can use PPDF's extract module. This requires a few steps, but is fairly trivial. Oh, interesting. So if it seems like what we're doing is, and we saw this in the help, that PPDF has an interactive, like a console mode, right? And so if we give it text in a script that uses its command line syntax, like extract.js, then it presumably reads that and then can go for it. Let's try it interactively though, just to see. And let's do can we just load? Okay, so if I run help on here, yeah. Okay, so we can do extract, and then awesome. extract.js. Cute. So look at that. It said PPF JavaScript code located in object 6 app.alert THM. Luckily, this isn't harmful. Sorry, I have a frog in my throat today. Okay. So THM. Luckily, this isn't harmful. I guess we just got a flag, although I wasn't expecting it. Okay. The advert PDF actually has an embedded executable. Look at the extracted JavaScript. We can see the following. Okay, so we'll do that. Let's see if we can just drop the flag in here real quick, and then we'll go back up and read this. Okay, so that was the flag. And then it asked how many types of categories of suspicious elements are there in not suspicious.pdf. Well, we got that as well. It said suspicious elements, open action, JS, and JavaScript. So that would be 3. And now we will, what do we quit? Yeah. So then we will do the same thing, but we'll do it with advert.pdf. Okay, so that says that there are 6 categories. Interesting. And we'll do the same thing. We'll do extract.js. Okay. This .export data object, CNAME not suspicious, and launch. Now I saw some text editor up here. What are we doing with that? Okay, so that export data object, what does that mean? When the PDF is opened, the user will be asked to save an attachment. Oh, interesting. Although PDF attachments can be zip files or images, in this case, it is another PDF, or is it? Okay, yeah, so whatever it extracted, right, was plainly an executable. We can see that from the MZ bytes right here, right? That's for Windows portable executables. And this program cannot be run in DOS mode. That string is at the beginning of every Windows executable as well. And then the rest of it, you know, it looks like, according to this, it would be, yeah, 4444 would be a tell that it's lazy Metasploit, right? All right, cool. That's fun. Let's go check out our malicious office macros. That's our next task here. And this one I really like doing in Linux. I mean, you can set up a Flare VM or whatever, but I really like doing it in Linux just because I have this sort of control over the macro enabled document. I know for sure it's defanged, right? Because even if I open it in something like LibreOffice, I'm not going to be executing any macros. Okay, so that's... Are we just talking about macros here and maldocs? Right. Okay. So we can use REMnux's vmonkey, which is a parser engine that is capable of analyzing Visual Basic macros without executing or opening the document. That's neat. All right, let's try that against the document. We're doing definitely a legit invoice. So vmonkey. First of all, let's always run the help, see what it can do. Oh my. Okay, so vmonkey can take in zips, emulate starting at the given function name, display potential IOCs. Okay. So we'll just fire it off without any options and see what happens. So vmonkey, definitely legit invoice.doc. And what does it give us? So let's read the output from the beginning here. Starting emulation. No module named Uno tools. We might have to install something to get that working, but that's okay. All right, so there's a function called defo legit, and it runs mshta against to download mydropper.exe. Okay, cool. That Uno tool seems to be an issue. And then found possible intermediate IOC. So it's showing us IOCs. This looks like XML stuff that it found, just URLs, right? This, though, isn't, right? This is obviously 4444. My first guess would be that it's Metasploit, just because that's lazy. So there's the calling procedure here, which we saw. Cool. What is the name of the macro for definitely legit invoice.doc? That was defo legit, right? Well, that was weird. I've been having the strangest problems with system audio. Okay, so what is the URL in the macro in taxes? Oh, okay, so now we're going to do the same thing for the taxes document. So it does give us quite a bit here, right? Where we have mshta again, going to tryhackme.com/notac2server.sh, and then whatever that does afterward, right? Copy this from here. All right, so we've learned about heap df and we've learned about vmonkey. Really cool. I will say that that's a lot easier than the OLE dump tool that I was using before, which is from Didier Stevens. Really useful, but a little heavy. So, just out of curiosity, is vmonkey available in Kali? No, it is not. Interesting. So there's a reason to use REMnux kind of specifically when you're doing malware analysis. I've done malware analysis in Kali kind of a bunch, but it's kind of neat to know that there are like dedicated, that the tools in REMnux are dedicated and specific for this. And actually, let's go check out the REMnux documentation to see how it recommends doing. Let's just search the documentation for PDF and see if there's anything there. Oh man. So it just has all of these tool listings for what you can do. That is crazy useful. I like that a lot. It even has the .NET analysis tools in here as well. That's interesting. All right. So moving on. What are we doing now? Ah, good. We're disassembling something. We're going to talk about entropy. Hey, chat, who has a good definition of entropy? So, I mean, entropy, measurement of randomness. Yeah, Hefty Pegasus, in this particular context, it is what that is. That definition always kind of bothers me because it obscures, its original meaning, which is essentially disorder, right? Entropy is originally like the measure of how much disorder in the universe allows energy to, energy can neither be created nor destroyed, but it can change form. And here's the thing, there are certain forms of matter in which the energy from it cannot be easily extracted, and entropy is the measure of that, right? And so when we talk about entropy in terms of a file here, or anything else like that, you're really talking about like how chaotic, how disordered the file is. And the more, like in Tenet, I never saw Tenet, but I'll take your word for it. The more disordered it is, the more likely it is to be something suspicious, because that disorder is an indicator of obfuscation. Does REMnux enable multiple VMs like Cuckoo? You know what? I don't know. In fact, Morning and Shell, I don't know what Cuckoo is. Tell us more. Oh, sandboxing? I mean, it's designed to run in a VM. There's actually something I wanted to do today that was kind of related to that. So weird. Yeah, so by the way, I wanted to shout out today, I have just signed up for a new-ish malware sandboxing tool, and so far it is the best one I have ever used. This is neat. I don't think REMnux is really designed that way, Born Again Shell. It's mainly for analyzing files and PEs as a VM itself, rather than working as kind of a hypervisor for VMs. This is cool though. This is neat. I'm gonna look into this. Thank you so much for shouting this out. Let's put that in the chat so everyone else can go explore that. That's really, really cool. But yeah, so the other service for sandboxing that I just signed up for, and it works fantastically, is Hatching's Triage. It's wild, man. So one of the things that I really had a problem with any run, which is what I was using previously for sandboxing, is that on the free tier for any run or any.run, and I love the analysis that any run does, but by default for free tier accounts, you could only do Windows 7 and only 32-bit. And with Triage, if you submit if I click on submit here, We'll go through this. Actually, we'll run one of these. But basically, you can fully customize what you submit. Actually, I should have a malware sample in here somewhere. Yeah. Let's give it one of these. Oh, I'm trying to drag and drop from my host to the VM. That ain't gonna work. We'll do this later. But it gives you the option to do 64-bit VMs and even customize it. You could even do Linux VMs. It has a full array, and I thought that was really, really cool. You do have to sign up for an account. You do have to get your account verified, but it's still free to do this. And so I don't know how they're making this work, but I'm very impressed. Let's just check in on our Ubuntu VM here. Okay. Great, so the Ubuntu VM is like kind of ready to go. I've just set up the new machine. Oh, didn't want to do that, but that's fine. All right, so now we're going to fire up terminal, not Firefox. God, it's so long since I've used vanilla Ubuntu with the GNOME shell. This is not my daily driver. Add to favorites. Okay. So the documentation for this is like what? So we're gonna install from scratch. We did that. Okay, so the first thing we do is wget. I wonder if I have copy paste. Probably not. No. Okay. Well, that's fine. So we're gonna wget HTTPS. Actually, let me cd downloads. Wget remnux.org/remnux CLI. And chmod +x remnux CLI. Chmox is not a command. Let's try that again. Okay. And then mv remnux CLI remnux sudo mv remnux. They want me to put it in, I think, what, user local bin? Yeah. We had a privacy discussion about sending our files for analysis in the cloud. Hey, Born Again Shell, you know what? So did we. And I think you have to be careful, right? If there's, you have to analyze it. I think you have to analyze it first in-house to guarantee that there's no PII, or in our case, PHI, that you're, sensitive information that you're disclosing. There's also, I mean, services like, different threat intel platforms or even different MSSPs will allow you to submit files for sandbox runs in them, and those are private, and they even will kind of have private Joe sandbox accounts or whatever else for you. And I think that's often, if you can afford it, worth the money if you're doing malware analysis in-house. Okay. and then just sudo remnux install, right? GNU-PG is already installed. Yeah, sudo remnux install. So we'll let that run. And back to try hack me. That's hack the box. Let's add an hour to this just in case. All right, Entropy would be a very good description of this stream since it's a little chaotic. REMnux provides a nice range of command line tools that allow for bulk or semi-automated classification and static analysis. Right, so here's an example, right? This, if we look at the bytes of this file, they're very, very orderly. Whereas this one, because each byte is so different from the next, or from the last, it is high entropy, or highly entropic. So we're talking about packers. Packers, okay, not an apostrophe, because we're talking about the plural, not a possessive, but packers use an executable as a source and output. Oh my god, this is killing me. Outputs it to another executable. Okay, friends, if you are writing something for public distribution and you would like a second pair of eyes on the spelling and grammar, I'm going to put it out there right now. Shoot me a DM. Join the Discord. Come talk to me. I will happily, before I was in IT, I was an English teacher. And so I will happily help you review your writing to make sure that it's on point. So executables have what's called an entry point. When launched, this entry point is the location of the first piece of code to be executed. Grammar matters. It does. When executable is packed, it must unpack itself before any code can execute. Because of this, packers can change the entry point from the original location to what's called the unpacking step. Okay. So packed files will have a high entropy. I think the easiest way to think about packers is, you know, other than the football team, which we don't have to think about at all, is if you have this entry point in your code, generally speaking, with a packer, it may change the order of where you're looking first, right? So again, in terms of the orderliness or the entropy of the code, you're going to have a lot more back and forth in a packed executable. The unpacking step will begin to unpack the executable into its original state. Once the program is fully unpacked, the entry point will now relocate back to its normal place to begin executing the code. Right. Okay. So packed files will have a high entropy. There are very few imports. Packed files may only get a get proc address and load library because they're all loaded within there. Okay. That's 34 imports, so noticeable amount. The imports are quite revealing what we can expect the application to do. Got it. Not so much here. What is the highest entropy a file can have? Presumably 1, right? Does it go the other way? Is it 0? Should probably, was it 9? Oh, 8. It's right there. Name a common packer that can be used for applications. To the Goog. UPX. which I think was in there. Yeah. This is like, I mean, I appreciate the theory here, but I wanna go analyze some malware. Okay, so this is memory forensics, right? So volatility is also loaded into REMnux. So if you want to do analysis of like a disk image, or a memory image rather, you can definitely do it using REMnux. You are going to be analyzing the memory dump I've taken of a Windows 7 PC that has been infected with the Jigsaw ransomware. The memory dump can be found task 6. Okay, Win7 jigsaw.raw. So let's just kind of get started with that. We'll do, if volatility is in here, volatility, and let's just remember our volatility command line options. I think it's -F for the file, right? And then the plugin that you want, or the module that you want to run. This is old volatility. Let me expand this out a little bit. And the first thing that we always want to do is run image info to make sure that we're going to use the right profile. Because if we don't, it won't read the memory correctly. So the first thing we're going to do is volatility. I can spell volatility-f jigsaw.raw, and we're going to do image info. Oh, good. It's what I'm glad that when I do stuff off the script that it actually matches what the instructions are. Wait, this could take hours to complete on a large memory dump on an instance like that attached to the room, so instead I provided for you. Oh, okay. Well, never mind then. So we're using Win7 SP1 x64. Great. Yeah, so we'll start with PS list. Profile equals Win7 SP1 x64, and we'll do PS list. I tend to prefer PS tree, but PS list is fine. Take your time. Checking in on our REMnux VM. It's still installing stuff. Hey, John. I think it's hard for me to see the YouTube comment names. Okay, good. We got some processes. Let's see what we got. So Dropbox, Office click Tor. That's weird. Click to run maybe. SBC host, Greenshot. I mean, I'm not expecting to see anything evil here yet. LSAS, some service hosts, spool SV. Nothing particularly exciting here. DLL host. Could be weird, but maybe not. Now let's do PS tree. So that we can see the child processes. Yeah, see? That's what you want. Right, so Explorer has VM tools, Greenshot, Chrome, VM3D service. I don't know what that is. So WinInit has these kids. SVC host, right? The WMI provider is running, which might mean something happened over WMI. We don't know. Okay. But yeah, Google Chrome is running, right? So in this case is Dirtbox. Yeah, because I think they actually name it Dropbox.exe with a PID of 3704. So we want to do DLL list on the process ID of 3704. And that will tell us all the DLLs that particular executable loaded. So it's loading kernel 32. It's loading cryptographic stuff, which is, we don't know why it's doing that. Shell 32, so to run shell commands. Forms. It's loading stuff to create UI components. GDI plus, so it's doing something graphical. Okay. Yeah, I was gonna say, this by itself is not, a tell, because there are things that use crypt-based legitimately to do actual encryption. But we don't know what this process is, and it's loading crypto, and it's loading shell. So it's suspicious at best. We found enough evidence to suspect ransomware through memory forensics and research. I guess because of the premise, right? The premise is that this is the image that we took it from. So, yeah. And actually, this explains a lot, right? Because if this is what we were looking at, look, you're looking at a window, right? With forms and obviously doing encryption. So this application, just from a single look, explains a lot of the DLLs that we saw loaded. Right, the form to fill out forms, GDI plus to actually even draw the window. So yeah. All right. With that, that's it? Man. The REMnux installer is still going, although I'm hoping that we're getting close to done here. So chat, I'm going to ask, is there any kind of not ransomware, any kind of malware that you want to review? Since we just finished this REMnux room on Try Hack Me. Let's review where we can, you know what? Here's what we'll do. While we're still waiting for the installer to finish, why don't we take a second and look at that Conti dump? Thanks, Hefty Pegasus. Thanks for hanging out. Enjoy the rest of your day. Oh, the Pegasus stuff? Oh, you want me to do mobile? Oh boy. Well, okay. I might have to fire up my Flare machine for this if it's still valid. This is just the jar, so we can play with this too. Maddie Stone is this great, this great course on Android app reverse engineering. And one of the first, the first thing that you really need is, I'm pretty sure, Android Studio. Oh, actually, you can do it with Jadex and Ghidra? Okay, well, neat. Let's just do it there. You got it, because I already have Ghidra on here, plus Cutter and everything else, so we will do Pegasus, Morning and Shell. At least to start. So let's grab this APK. And let's see if there are any... So Hatching Triage actually ran it, but let's run it on Hatching Triage as well. So we're going to download the sample. We're going to download this. Let's throw it at Hatching Triage just so we can see what that looks like. And give it the password here. And then again, just love this. Absolutely love this system. right? Where you can decide that it's internet accessible. You can set it to access through Tor. You can do Android if you want, which we'll keep it to automatic to see if it picks the right thing. I mean, it's an APK, so it knows what it's doing. And then we'll fire it up. Now it'll do a static analysis first. And you see that we have the static tab. But look, it's in real time, right? Firing up the Android emulator. I think that's really cool. Okay. So I have JADX installed now. Yes, I do. Report is done. So notice the difference between the static and the dynamic analysis. So the dynamic analysis didn't actually show us that much, right? We saw there was like a request to this ad network. There was some stuff going on, DNS here, right? The 5228 is kind of interesting. Up and down. By the way, we can download the packet capture. How great is that? I don't know. I think that's rad as hell that you're able to get the whole story from this. So, you know, we'll fire up Wireshark and take a look at this PCAP to see what it saw. Because even though its analysis didn't see anything, you know, our eyes might be able to see something else. Any files created? No registry. That doesn't really make any, right? Oh, and you also have the net flow here as well. Oh, they even give you the JAW3 signature? Man. The more I look at this thing, the more I like it. But then the static analysis, right, was a totally different story. Now, the reason why, of course, is because it already had the sample provided before, so it has a disposition for it, right? The hash matched, and so it gave us this. Nevertheless, we might be able to see something in there. We're also going to decompile it and you know, do all that. Come on. Wireshark, where are you at? Okay. Let's so we'll unzip this thing. Website block due to reputation, website triage. Malware bytes browser guard blocks pages that cover websites. Relatively light traffic reported. You trust this website, please? Weird. I mean, it's a legit site. All right, so we have JADX. Oh, that's the issue. Okay, so we got an APK in there. Good. JADX, and then we'll give it .apk. Notice that it needs the absolute path Cool. Love to see all these errors. That's it's exciting. Ghidra it is then. I know this isn't the latest version of Ghidra. I gotta update my VM. But that's fine. So we'll do a new project. Okay, import some files. All. How's our REMnux installation going? Still going. They did say it would take a while. Look at all the stuff that it's setting up here. OpenJDK, Salt, ClamAV, Docker. Cool. Okay, so Born Again Shell. I think I understand. I think I understand the issue. You got to be doing this not on your host system with malware bytes enabled. So this is a pretty important part of malware analysis. Like the whole, from start to finish, do this in an isolated VM because you don't know what you're going to be downloading. Malware bytes is right to be yelling at you about going to this site. But yeah, you wanna be doing this in a VM. I don't want you to download malware onto your host machine. Okay. Now I'm gonna bring up Maddie Stone's course material. Android stuff is not my so Athena. Okay, so we have a binary here. Yes, let's analyze it. Cool. All right, let's look at defined strings. See if there's anything interesting in here. Stir copy. All right. Was this just the emulator? Here's our entry point. We go to libc init. This is all libc. Not what I expected. Oh, we want to run JADX GUI. That's better. This is closer to what I was used to seeing. Okay, cool. Yeah, now we're cooking. Okay. So here's our source code. Resources. Android manifest. You start here to learn something about this thing. So this is Lenovo Safe Center. Okay. And I'll admit, I'm not, I didn't follow a whole lot about what was going on with the Pegasus stuff. So I'm going to look that up, right? No, that's really not what we're talking about. What is it, the NSO? Yeah. Was there a Lenovo component to this? Yeah, I mean, it was mainly for iPhones. It's interesting that there was an Android component here. That's what I thought. Okay, so what are we looking at? Android test runner. So intents are integrations with other parts of the, like, features of Android that you're going to want to use. So Lenovo Health Check is the name of this thing. Okay. There's a phone number in here. For an SMS test, it looks like. Interesting. Who wants to text that phone number? Let's look at classes.dex. It's got a sign from Lenovo. All right, so let's go look at this thing. I believe if we go back to the Android manifest, there should be an entry point. Or something like that. What is the MVT project? Mobile verification. Oh, neat. It has been developed and released by the Amnesty International Security Lab in the context of the Pegasus project. Download all or non-safe listed installed APKs. So what does it do? I think this downloads samples so you can check it against what you're... How to catch NSO groups Pegasus. Discovering Pegasus network injection attacks. Okay, so we've got some IOCs here. Yeah, and I think what it does, Born Again, is that it downloads like kind of known samples and then checks your thing, or allows you to check your thing against them. Yeah, application entry points, launcher activity. That's what we want. Okay. Main tab dot splash activity. Yeah, so launcher activity, then all right, so we still have more to explore here. And I think I want to start Android. The view. It's decompiling, so we're going to look for stuff. For splash. There it is. So we found it. Not entirely sure where. Oh, in COM. There we go. COM. Lenovo, here's the stuff, right? Safe Center. This is all the actual code here. So main tab splash activity. So this is actually where the application begins. And it's decompiled, right? So we're looking at the Java, essentially, that makes it happen. So we've got some variables getting declared here. Okay, so we're looking for function calls out of here, right? So basically, this is like the main loop of the application. So what we want to see is anything that goes elsewhere. And we have like send empty message. That might be something to check out. We can go to declaration here and find it. So these are not remote messages. These are application messages. It's not like they're sending an SMS or anything. It's like it's message sending within the application for events. What a name, white person provider? I don't think we need one of those. Let's take a look at the SMS notify activity. I mean, I'm not seeing anything that's shouting out to me that it's like super evil here. That's not how you spell Pegasus. See if there's any write-ups about... Right. Let's go back to the report here. And actually, let's go get the hash. Let's go send this to virus total. And let's look it up across all of our tools. What? Interesting. Oh, but we don't have to do that because we actually have the links from Malware Bazaar. So let's take a look at what Joe Sandbox has to say. Called it malicious, but why? Let's take a look at the report. Registers a broadcast receiver to intercept incoming SMS. So we actually did see that. Call com.lenovo safe center support security service register receiver. Creates SMS data. So a lot of this we did see. Let's go all the way back to our Android manifest, and you'll see that we found, right, all that SMS stuff. Let's actually even search for SMS. Right here. Lenovo background, send SMS. That's interesting. And we found some, so com Lenovo Safe Center. I believe, yeah, we saw broadcast. So here we go. Let's take a look at these. Send SMS service. We're going to find usage for send SMS. So there are two places where this is used. The first is, this is the declaration, but this is its actual usage. And we're in, yeah, on start. I'll find the usage for on start. Interesting. So yeah, I mean, I think the question you have to ask yourself is why the hell would a Lenovo Safety Center thing require SMS permissions? That's weird, right? And it definitely doesn't need to know whether you've received one. And look at all these permissions that it requires. Read SMS, make phone calls, kill background processes, get your get your location. Look at all these permissions. And I think, you know, I'm still learning how to do a lot of this stuff. Why does it need to wake your, wow. Bluetooth. As I'm learning more about Android stuff, you know, one of the first things I think I should look at is what permissions does the application have, and does it ask so much more than what it really requires? Now, I don't know what Lenovo Safe Center is supposed to be. I don't even know why you need it on an Android phone anyway. That the fact that the first thing that comes up is from APK's hub does not instill me with a lot of confidence. No, I will not. I will not be downloading it. But I have a feeling this is what we're looking at, right? So it has a legitimate certificate, but this is not from Lenovo. So let's go back to that main tab, you know, splash activity. So let's see if there's... So you can search by actual name. If you search for com.lenovo.safecenter, I'm pretty sure you can search by those still. Very funny that the the Joe Sandbox report is result number 2. Yeah, I think it got taken off the Play Store, if it was ever on there. So they have a special image for holidays? Okay. Splash activity extends activity, implements observer. Let's look at the SMS notify activity. Track event. Let's go see that. com.lenovo.safecenter.utils. This is the Safe Center stuff. So look at these function names. Good God. What? I mean, like... What are we looking at here? Harassment activity? I believe that despite the problematic naming here, the white person, black person thing here is essentially an allowed deny list. I think it's an allowed deny list because what we're looking at here is at the very end, we're looking at like get harassment count, right? It could be wrong, but I'm pretty sure this is not a race thing. Yeah, you did. Now, It's referring to this content com.lenovo safe center local black provider. Okay, here we go. Here's your white person provider. Let's see what this says. So it's running its own SQL, its SQLite database. Insert white person. Yeah, we're gonna pull on this a little bit. Okay, so it's in the anti-spam. So we're in Lenovo anti-spam. Let's take a look at what we have here. Sort of the same thing, right? Here we go. Get harassment status. Let's go back to the manifest to see if there's anything like URLs that we can use. Not so much. Oh, there's a lot of these. Here we go. Here we go. So we've actually got URLs now. Here we go. Now we're getting somewhere. Look at this. LPS Reaper, huh? That's not at all weirdly named. Let's quickly do a dig for Lenovo MM. Seriously? Was it like NetUtils or something? I think I ran into this before and just got annoyed. So NetTools is in here, but dig somehow, whatever. Yeah. Is it NetUtils? No, I think it's NetTools Born Again, which is installed, but for whatever reason, dig isn't part of it. It's fine. So it's a C name for amp.mbgstore.lenovo.com.cn. Maybe. Yeah, I'm probably not going to find it on Aaron, huh? Great. Thank you. So it's an Akamai IP. That doesn't tell us anything one way or the other. But this does. Ideal123.cn. The other thing I always like to do is go to, well, we've got virus total up, right? No detections there. I always like to go to Cisco Talos as well. Hello. What the hell is this? Upload server 3G. This looks just weird. This looks like the kind of thing that I'd have concerns about. Not detected, though, but that doesn't really mean anything. I mean, it does, but... These were not compiled, or decompiled. That's interesting. This is like the... This is like the kind of opcodes for the Java, not the decompiler. That's a weird one. Let's see how this installation is doing of REMnux. Been a minute since we've checked in on that. Still not done. Impressive. We might have to do a part 2 of this next week. Okay. So we don't know exactly what this was doing with this upload packet info response. So I'm extrapolating a little bit here, but let's talk through what we know about this particular Android application. We know that, first of all, it was flagged as part of the Pegasus op. That's one. Two, we know that it's asking for way too many permissions, right? It's asking for whatever it's claiming to be, the Android Safety Center, whatever it is, or the Lenovo Safety Center. It's asking to access the internet, do all the things that you can do with your phone, send text messages, receive text messages, make phone calls, read your calendar, write to the calendar, make contacts, read your contacts, write security settings, right? Kill processes. Basically, full control of your phone. That's bananas. There's no reason it needs to have all this. And then we know that it is definitely sending text messages, confirm that it has that capability. How does this list of permissions look like on a prompt? It'll look large. You know, Born Again, you know, it's funny. I was having this conversation with somebody the other day. It's like, to you and to me, it would look obvious. But a lot of times people... they just zone out when there are pop-ups on their computer. They just do. They'll just say, I'm trying to do a thing, I'm trying to install this, whatever, and they'll just click through whatever the computer's trying to ask them to do to get them through it. Security is not a top of mind for them, and so it doesn't trigger that red flag the way that it does for you or me. So we know it has all these permissions. We know that it sends test SMS messages, and we know that it has quite a bit of... so it's got this Lenovo stuff. I'm not really sure what that's all about, but this... okay, we can check this out. dev.surepush.cn. There might be one to look up as well. No detections there either. Yeah. With this, you barely would have to root the device, you know? Assuming this can receive new instructions and perform tasks, there's all sorts of stuff that it can do without even, you know, getting root, per se. But yeah, look at this. It does have a Ledroid loaded up. Yeah, I don't think that's what it actually is. Because look at this. I think we found it, friends. So this Ledroid thing, right? Let's go back to the manifest and look for Ledroid to see if there's any reference to it and what it's supposed to be doing. There is not, so now we're just going to look for it in general. I'm looking to see in com.lenovo anywhere if it's described. Yes, it is. In the utils. So if we look in utils, what is it? Const? Let's take a look at const. Yep. Ledroid Service Launcher. Uh-huh. Get out of here. All right. Now this looks like some evil that I'm used to. Is the phone root, or, you know, root the phone. That get holiday image URL was some BS, I think. Cute. See if there's anything in constant here. No. Let's look at WFL utils since we saw that. Let's go back to this the Ledroid here, the shell command stuff. So it looks like this is just the way that it sends shell commands in. Let's look at the shell terminal controller. This might be fun. Okay, so we have this thing that runs shell commands, which, okay. I am not sure. I am not sure how it self-destructs. So on installation, it does start using const. Mm-hmm. That's not what APKs. Damn. Equals an SMS. Saw activity equals this. Database TV app. Send message. Okay. Wait, what? Has virus? So there's interesting. So Ledroid has its own thing in here. Look at these phone numbers. Maybe they're not phone numbers. They look like American phone numbers to me. Apparently not, though. That's just a thing in Android. I think we've mined about as much of this as that, at least in my capabilities, I can really do. But we definitely found some really suspicious stuff on here. Obviously, it appears to be creating some sort of shell wrapper that allows communication directly into the phone. It has way too many permissions. So this was cool. So next week, what we'll do, well, actually, no, not next week, because I am taking a break after Hack Summer ends. Week after next, we will continue with REMnux and do some malware analysis in that tool. So until next time, friends, thank you so much for hanging out. Hope you have a great rest of your weekend. Let's see if there's anybody else streaming right now. Not that I have on the... Yeah, mainly, you know who's streaming? It's DEF CON. So go check out some DEF CON streams. I would recommend the Blue Team Village, since that's what we were doing today. So go check out one of those, and let me send you to the InfoSec stream so that you can see them. So until next time, be good to yourselves, be good to each other, and happy hacking, everybody.